Okay, hey everyone. Today we're going to solve this problem that is LeetCode 953, verifying an alien dictionary. As you can see, this problem doesn't have a very good like to dislike ratio. Although it's not that bad, but yeah, it's not that good. And it's an easy level problem, so let's see. The reason why I think that a lot of dislikes, this problem has a lot of dislikes, is primarily because I think the question could be misunderstood in a very easy way, and problem statement should be more elaborative in what type of comparisons should be made. Because in this comparison, we can see that each word should be checked. Yeah, right? Okay. So let's jump to the statement, and then I will let you know what do I think about this problem and what's wrong with the statement. So in an Indian language, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in this alien language. So, by this statement, and this statement is not enough to make us understand what the question is asking. By looking at this test case, it could be made clear, but this is not a good way to understand the problem. Although this problem could be understood, so that is why the dislikes are not more than likes. But the statement says that you are given hello, and then you are given lead code, right? And then you given an order that how the ordering of the alphabets are. Now you will compare with each word and the next word, and you will see if this array of strings, that is word of this words array that have different words in it, are sorted or not. And as you can see, h is smaller than l, because in order h comes before l, and l comes at the second place, and h is at the first place, and h is before hello is before lead code. So this ordering is correct and this is true. But in this test case, we have word, then we have world, and then we have row. So in this case, you can see WOR. We are making comparison with the adjacent character, adjacent word, and WOR same. But now we have D and then we have L, and here you can see that L comes before D. So this word should be placed at this position and word should be at second position, which is why this is not a sorted order and we are going to return false. Similarly, for this test case, we have apple and app. The order is A, B, C, and okay, so the basic order that we have in our on our Earth planet, whatever, and we have A double P and A double P, similar characters, but we have L, and there is basically in string we say that if there is no character, then there's an I think an n pause or an empty, null character, and a null character will always be lesser than will not actually lesser, but if we are making a comparison, then this character should be preferred because it has some values, it has some characters in it, and doesn't have characters in it. So as you can see that L will be greater than the phi, and phi is basically a blank character in a string. So this is the problem. Let's see how to solve it. I don't think that we need any annotations for this problem because this is a very simple one, but still I will try to give you an example. So this is the so order is given to us in this way, and these are two words. What we can do is we can make comparisons that h and l. Okay, so if they are same, then we will move to the other characters and we can make them comparison. And if h is in the order, we have h that comes before. And for example, now we encounter characters that are not equal, that are not same, and that is the point where we will be making comparisons. That if h is smaller than l, then h needs to come before that. But if l is smaller than h, then this is a wrong, or this is an unsorted sequence of array of words, which is why we will be returning false. Otherwise, if every this scrutiny test is passed by this algorithm, then at last we'll be returning true. So that is why I think the primarily reason why this question is so disliked, because it can be misinterpreted in a way that rather than comparing H and L, like which I had also done, that I was comparing HELLO, and I understood the question in a way that we need to check if every word is following the order or not. If there is any single word that is not following the order, then we'll be returning false. But that is not the question. And another thing, that this is an easy level problem, although the implementation is not, well, I will not say that it's difficult, but it's not that easy. So I think why it is an easy level problem, because test cases gives out everything. Like this test case is very explanatory and very helpful, and then you have the third test case which is also very helpful. So I think this is the primary reason why this problem is easy and a lot and disliked to this extent. So yeah, we are done with this, and let's see the algorithm, and then we will have our analysis. What is the time and space complexity for the same? So first of all, we need an unordered map. Why do we need that? Because the order of the strings, that is or of the alphabet that is given to us, we need to store their order, that H comes before that. And how we can store that? By mapping H with the index. So H is 0 and L is 1, and this could insinuate that H is smaller than L because it has an index 0 and L has index 1 that is greater than H's index. So we need an unordered map of character and int, and this will be order index. Then for reference, you can have a character that is current char and next char, and we will be using them at the later part. Now we need to construct the index. So I will say I is equal to 0, I is less than 26, because that will be the size of the order string, and I plus plus, and then I will say sorry, order of I is equal to I. Now we need to for every word we need to make these comparisons. So what we're going to do is int I is equal to 0, I is less than words dot size minus 1. Why minus 1? Because we will be comparing the current word and the next word. And when we are doing an operation that is I plus 1, and we need to be aware of the fact that I plus 1 could give us an out of bound issue if we are not subtracting minus 1. Now we need a j variable in order to traverse over the word, and j is less than words of I dot size, and sorry, j plus plus. So the first thing is if there is an empty character, right? Which means if j is greater than words of I plus 1 dot size, if this is the case, so if j is greater than or equal to, yeah, so for example in this case as well, apple, so this is a double p and a double p are same, right? But L is greater than the blank character, so apple app should be at index 0 and apple should be at index 1. Basically they should be swapped, which means the order of the words that is given to us is not sorted, and because of that we will be returning false. So if this is the case, that the current word, that the on the ith word which we are looking at, and it has more characters as compared to the I plus 1th word, and that is not something that we stand for, so we will be returning false. Now other thing is the character comparison. So I will say current character is words of I at jth place, and the next word character is equal to words of I plus 1 at jth place. Now the thing is, if current char is equal to the next char, then don't do anything, just continue the loop. But if the order of index of current char is, let's say the order of index of current char is greater than, right, and the ith character has a character, the ith word has a character which has index greater than the I plus 1th word jth character, next word jth character, then it would be a problem. And order index next char, then it's a problem and we need to return false for that. Else we can just simply break out of this string. And why we are breaking out of this string? Because if it is a equal character, if they are same characters, then we can just simply continue the loop until and unless we find that there are different characters. And if they, so let me just write it here. So this is same characters, now this is different characters, and at this place you will see that if that the words of I dot size is greater than words of I plus 1 dot size. Okay, that the ith word is greater than the I plus 1th word. And yes, so at this place you will be saying that the current character from the uh, from the current word, the jth character has an index that is greater than that. Then we'll be returning false, that we don't need to look any further, and this will have a false output. Otherwise, if there are different characters, but the order is satisfied, then it means just break out of this loop. We don't need to traverse, we don't need to compute this ith word, and we can simply go to the I plus 1th word and compare it with I plus 2th word. And if everything works out, and if everything is checked thoroughly, and false is not returned, then I will say that there is no bad option in this algorithm, in this process, and we can just simply return true, that the sequence of words that is given to us is okay, is good. And yes, it is um, performing good on time part and in memory part as well. So the analysis, now coming to the analysis, I think, so first of all, at every word we are comparing strings, right? So if there are, let's say there are, okay, so time function will look something like this. Initially we are doing 26, we are iterating over the order string that is given to us, and it's of the size 26, so which means it's a nothing but a constant size. Then we are iterating over the words, and if the word size, length of the word size is n, then it's big of n. And if every word has an average length of, let's say, m, then it's order of m. Sorry, then um, for every word that is present in this words array has a length of m, then this is order of m. And the time complexity will something be like order of n cross m or order of n cross m. Although constraints are weak, which means n 100 and words on, so this is nothing but a 2000 something. And for 1 second time, especially on LeetCode, we have 10 raised to the power 5 constraint, which means that it can easily be done in 2000, even if we have 0.5 second or 0.25 second. Now space complexity, so we are using an order index, we are using order index map, and it is of 26 characters, which is just nothing but a constant space. So time complexity will be order of n cross m, and space complexity will be 26. Okay, order of 26 or simply constant. So this was the problem, and if you want to try this problem yourself, problem link is given in the description. If you want to check the source code, the same code that I have typed here, then you can also check the source code. A gist link is provided in the description. So thanks for watching and have a good day.